Hi guys, Professor Latimer here, the CC mom who loves science, and today we're going to talk about Cycle 2, Week 9 Science Experiment, which is all about rockets. It's one of my favorite things. So this is just going to be a really fun day of experience for the kids. So the Foundations Guide says you can either get real rocket kits and go outside and launch rockets, or if you want to do it indoors, you can get Stomp Rockets. And so you could get those. I've seen them like at Hobby Lobby or at Walmart, or get them off of Amazon. One thing we did last time we did this cycle was we kind of created our own Stomp Rockets. We took a 2-liter bottle and there was a hose attached to it, and I think they were on a stand, and so the kids would jump on the 2-liter bottle and their rocket would be at the end of the tube and it would shoot up in the air. So we had like a big auditorium area, and so that was a lot of fun and the kids really enjoyed that, and they got to kind of help create their own rockets. So you could find templates and designs for just like paper rockets online. You can take like construction paper or cardstock even, and make tubes, and there's little templates. You can make a nose cone and fins, and so our students got to pick out, okay, what color paper do they want their rocket to be, and parents helped and tutors helped tape together the rocket. So each student had their own unique rocket, and we got to do the Stomp Rockets inside. So that was a lot of fun. So either way, however you go about this experiment, we're going to learn a little bit about how rockets work and why rockets are necessary. Talking about, we learned about gravity in some of our previous experiments. And so gravity is that force that pulls everything to the ground, to the surface of the planet. And so if we want to get something up into space, into orbit, like a satellite or a space station or astronauts, we have to overcome that gravity. We have to overcome that force. And so how do we do that? So we usually do that with a rocket. And so the Foundations Guide on page 191 suggests blowing up a balloon and letting it go and observing what happens. So when you blow up a balloon and then let it go, it shoots off in a direction. So the air comes out of the balloon, comes out of the opening of the balloon, but the balloon itself shoots off in the other direction. And this is an example of Newton's third law of motion, which we're going to learn about in new grammar eventually. So Newton's third law says for every action there's an equal and opposite reaction. So the air shooting out one end created a motion this direction of the balloon, and that's what's happening with the rockets as well. So I again like to use Nicole Liam's science scripts from CC Connected. She's got some really good questions and talking points, and she's got a diagram of a rocket. So what you have going on inside of a rocket, I'll kind of explain that a little bit. You have your payload at the top, whether that's your astronauts or your satellite or your pieces of the space station. So that goes at the top, and then you have usually a fuel, which can be hydrogen or RP1, which is just the fancy name for kerosene, just that combustible fuel. And then you'll have your liquid oxygen, and then those will mix. Your fuel and your oxygen will mix, and there'll be a spark that ignites it, and you'll have these flames that shoot out of the engine, out of the bottom of the rocket. And so it's just like the balloon we saw. So when you have that force and all of that thrust coming out at the bottom, it creates an opposite reaction and motion of the rocket going upward. And another thing that to note, you can talk about Newton's second law of motion as well. So that force equals mass times acceleration, and that's just saying that the heavier your payload, the bigger your rocket, the heavier your rocket, the more force it's going to take to get your rocket up into space. So that's something that scientists and engineers have to think about when they're designing rockets, or when they're designing something that's going to go into space. Is how heavy is this, and how big of a rocket, and how much fuel am I going to need? So they have to design their payloads to kind of fit into a certain size rocket, or just know, we can only make rockets so big right now. And so that's just something that they have to think about. And so this one is just a really fun day, a fun experiment with rockets. And you can do the Stomp Rockets. You can do the actual rocket kits outside, and where you'll notice, there's that combustion and that fuel burning to create that force going down, and then they'll observe that their rocket goes up into the air. And so some thoughts are, okay, how much fuel, how fast would it need to go into space? And it's interesting to think about too, like if you wanted to send a rocket to the moon, you have to go a lot faster than just getting something up into orbit. Because into orbit, you're still kind of in the realm of Earth's gravity. It's still acting on that object. And then we talked about the centripetal force that kind of balances it out and keeps it in orbit, keeps it from flying away or falling back to the Earth. But to actually escape Earth's gravity, it has to have a lot more thrust. It has to be going a lot faster to escape Earth's gravity. So there's a lot of cool things to think about and talk about, and just asking questions, how do we get things into space? And have you ever been to a rocket launch, or seen one on television, or met an astronaut, or been to a space museum and noticed the different shaped rockets, or the different sizes? And so, there's different size rockets to get different size satellites or payloads into space. And so just a lot of good questions you can ask, just lots of things to be curious about, and then also a lot of fun just taking turns having the rockets launch. So have a lot of fun with this experiment, and that's cycle 2, week 9.